Hello, tech enthusiasts. Today we're diving into the world of arrays in embedded C. Imagine you're working on a project, perhaps building a weather station. You need to store temperature readings from the past week. How would you manage this data efficiently? This is where arrays come in handy. Think of an array as a well-organized toolbox. Each compartment in the toolbox holds a specific tool. Similarly, an array in programming is like a container that holds a sequence of values. These values can be of the same data type, such as integers, characters, or even complex structures. Just like you access a tool in your toolbox by its position, you can access elements within an array using their index. This makes it super convenient to store and retrieve related data in your embedded systems. So, whether you're building a weather station, a robotic arm, or any other embedded system, understanding arrays is essential. Let's delve deeper into the world of arrays and explore their significance in embedded C programming. In the realm of embedded C programming, an array is a fundamental data structure that allows us to store a collection of elements of the same data type. It's like having a neat row of boxes, each labeled with a unique index, where you can store related pieces of information. These elements are stored contiguously in memory, meaning they occupy consecutive memory locations. This sequential storage is what makes arrays incredibly efficient for accessing and manipulating data in embedded systems where memory management is crucial. Unlike ordinary variables that hold single values, arrays provide a structured way to manage multiple values of the same type. This organized storage simplifies code and makes it easier to perform operations on groups of related data. Whether you're dealing with sensor readings, control signals, or any other type of data, arrays offer a powerful mechanism for organizing and processing information within the constraints of embedded systems. Arrays are the backbone of countless applications in embedded systems. Let's consider a couple of relatable examples. First, storing temperature readings. In our weather station project, we can use an array to store daily temperature readings. Each element in the array would represent the temperature recorded on a specific day of the week. Second, controlling LED patterns. Imagine programming a sequence of LEDs to light up in a specific pattern. We can use an array to store the on or off states of each LED. By cycling through the array, we can create dynamic lighting effects. These are just a glimpse into the vast possibilities that arrays unlock in embedded systems. From managing sensor data to controlling actuators, arrays form the foundation for efficient data handling and manipulation. Now, let's get our hands dirty with some code. Declaring an array in embedded C is actually a pretty straightforward process. The general syntax looks like this: data type, array name, and then the array size in square brackets. So you would write something like data underscore type array underscore name array underscore size. Let's break down this syntax a bit. The data type part specifies the kind of data that the array will hold, such as int, char, float, and so on. The array name is just the name you choose for your array, following the usual rules for variable naming. And the array size? That tells the compiler how many elements the array can hold, and it's always enclosed in those square brackets. For instance, if you want to declare an array named temperatures that can store 7 integer values representing daily temperatures, you would write int temperatures 7. This line tells the compiler to allocate memory space for 7 integers and associate it with the name temperatures. Once you've declared an array, you can access and modify individual elements using their indices. It's important to remember that array indices start from 0, so to access the first element of the temperatures array, you would use temperatures 0 in square brackets. Similarly, temperatures 1 would access the second element, and so on. For example, temperatures 0 equals 25 assigns the value 25 to the first element. Temperatures 3 equals 28 assigns the value 28 to the fourth element. And if you want to read the value from the first element, you could write int today's underscore temperature equals temperatures 0. Just keep in mind that the index of the last element is always 1 less than the array size. In our temperatures array, the last element is temperatures 6. You can use array elements just like regular variables in expressions, assignments, and calculations. This makes it really easy to manipulate and process data stored in arrays. While arrays are super powerful, they do come with a few common traps that can lead to errors if you're not careful. The first one is off-by-one errors. One of the most frequent mistakes is accidentally accessing an element outside the bounds of the array. Just remember that array indices start from 0, so accessing temperatures 7 in our example would be an error, because the valid indices are from 0 to 6. The second pitfall is uninitialized arrays. When you declare an array, its elements might contain garbage values if you don't explicitly initialize them. So always initialize your arrays with default values if needed. The third one is array decay. In certain situations, like when passing arrays to functions, they might decay into pointers. This can lead to unexpected behavior if you're not aware of how arrays are handled in function calls. To avoid these pitfalls, double-check your array indices to prevent out-of-bounds errors. Initialize your arrays during declaration or in subsequent steps, and be mindful of array decay by using appropriate techniques when passing arrays to functions. Congratulations on reaching the end of this deep dive into arrays in embedded C. You've learned about their definition, real-world applications, declaration, manipulation, and even the common pitfalls. Mastering arrays is not just about writing code. It's really about thinking in a structured and organized way. Arrays empower you to efficiently manage data, handle large sets of related data in a structured and memory-friendly manner, and simplify complex operations by performing actions on multiple values with concise code. This all improves readability and maintainability. Plus, arrays unlock advanced functionality because they serve as the building blocks for more sophisticated data structures and algorithms. As you embark on your embedded systems journey, remember that a solid understanding of arrays will be your constant companion. It's a fundamental skill that will definitely elevate your coding prowess and enable you to build more robust and efficient embedded applications. So keep practicing, exploring, and building amazing things with the power of arrays.